Assalamualaikum warahmatullahi wabarakatuh. Before presenting our result, allow us to introduce ourselves. Introduce me, Eka, as gentleman, and Linda Dayat Kalim are my research colleague, as well as Mrs. Zena and Mr. Farouk as our research supervisors. We are from Mechanical Engineering, Malang, Islamic University, Indonesia. We will present our result entitled A Study of the Turpentine Oil Addition on the Droplet Combustion Characteristic of the Crude Sunflower Oil as Biodiesel.
Motivation. The need for petroleum as the main energy source continues to increase along with population growth and technological advance. Given the limited source of fossil energy, especially petroleum and the increasing price of fossil energy, the use of energy needs to be optimized. Biodiesel is an environmentally friendly vegetable oils and can replace the increasing demand for industrial diesel fuel. Compared to fossil fuels, biodiesel fuels has advantages such as a biodegradable, higher certain number, better combustion efficiency, low CO2 and sulfur gas emission rates, and is environmentally friendly.
Sunflower oil has a disadvantage, namely its high viscosity, so it can cause engine performance to decrease and damage parts on the machine. Therefore, it is necessary to have the addition of additives. Turpentine oil was chosen as the fuel additive in CSFO because it contains alpha-pinene C10H16 turpentine hydrocarbon, which is flammable, has a lower viscosity, and it's abundant material, so that it can produce high quality in sunflower oil biodiesel and good performance in the engine.
Objective. The study aims to determine the effect of adding turpentine oil on the characteristic of droplet combustion in sunflower oil, as well as creating an environmentally friendly blended biodiesel fuel.
Why should biodiesel? 1. A breath of fresh air. When there are more vehicles in our neighborhood switch to biodiesel, everyone can breathe a sigh of relief. 2. Certificate clean. Biodiesel is labeled as the clean air choice by the American Lung Association. 3. A small carbon footprint. This biodiesel produces 78.5% less carbon dioxide emission than conventional diesel fuel. 4. Healthier community. Biodiesel help reduce the risk of respiratory disease.
Literature review. In 2020, Lawan et al. Conducted a research entitled Synthesis, Properties, and Effect of a Multifunctional Biodiesel Fuel Additive. The research produced biodiesel, which was processed through chemical reaction. The same is true in this research.
The installation of this theory is to use a miniature combustion chamber, which is likened to combustion chamber in a diesel engine. In the combustion chamber, there are two K-type thermocouples dripped by two droplets of a mixture of CSFO and turpentine. Thermocouple is propped up by two support ions with a predetermined distance. Thermocouple is directly connected to the data logger, which functions to record and combustion temperature. The data logger will be connected to a laptop to display temperature details in Excel form. In the combustion chamber, there is also a heater connected to a transformer as a flame lighter. The camera will be connected to a laptop that serves as a fire visualization recorder.
How is the method of mixing turpentine with CSFO? 1. Sunflower oil will be put into 2 measuring cups of 90 ml in the first measuring cup and 85 ml in the second measuring cup. Then turpentine will be added to each measuring cup by 10 ml in the first measuring cup and 15 ml in the second measuring cup. 2. In the slide image, we can see the structure of alpha-pinene. Then we can see the simulation of the interaction of alpha-pinene with the CSFO triglyceride chain. Atoms of the constituent elements of alpha-pinene attack to the triglyceride chain due to different electronegativity, causing an attractive force that activates the atom's mobility. This mobility potentially changes the geometrical structure of triglycerides to become more blooming, or chain spreading so that the distance between the carbon chains away from each other.
Experimental condition. This study used three variations. 1. Pure GSFO, or 100% sunflower oil. 2. GSFO10, or 90% sunflower oil mixed with 10% turpentine oil. 3. GSFO15, or 85% sunflower oil mixed with 15% turpentine oil.
Result and discussion. The graph show that CSFO15 is the right mixture because it has the best burning rate value of 1.08 mm square per second on channel 1, then followed by CSFO10 with a value of 1.26 mm square per second on channel 0. The nature of turpentine oil can reduce viscosity and accelerate evaporation, so that the bubbles and microexplosion in the droplets are reduced in a higher volatility and combustion rate. CSFO pure has a burning rate of 2.05 mm square per second due to the higher viscosity and surface tension than CSFO, which has been added with turpentine oil, so that the bubbles in the droplets are difficult to evaporate and the bubbles are getting bigger, which causes the droplets dimension to also enlarge. Calculation of the burning value. So a high value if the droplet diameter is enlarged because the burning rate value is directly proportional to the square of the diameter.
Visually, the higher the percentage of the mixture, then the burning time will be shorter. In addition, the phenomenon of microexplosion occurs most in pure CSFO. Good ignition performance is found in the CSFO15, which has a shorter ignition delay and less shot formation.
Conclusion. 1. It was reported that turpentine oil addition to CSFO improved the ignition quality. 2. CSFO15 and CSFO10 were ignition faster than that of pure CSFO at 0.6 second and 1.06 second, respectively. 3. The microexplosion phenomena were observed for all the test fuel, where the pure CSFO had the most. 4. The good ignition performance was found to be CSFO15, which had a short ignition delay and less shot formation.